Alright guys, check out this ugly thing I 3D printed. I wanted to make the pennies flush, but I ended up printing my holes just a wee bit too small, and then I thought I'd use a soldering iron to sink it in, and I accidentally touched it. So that didn't work, so I ended up using super glue. But the concept behind this was, what if unconventional things could be used as buttons for a computer or an embedded system? And here's our old handy dandy ESP microcontroller, which is flashing like crazy because it's reading data. Watch what happens when I touch though. Ooh, red, green, blue, magenta. And now watch this. There's a blend function in here. So we touch blue, we just barely touch red. And then the more we move our finger on it, the different the way the color changes. The different, it'll choose like whichever one has the more conductance. And then you can even, you have to go kind of slow with this one. Oh, so you can definitely get input into a system. We could have, you know, combinations like a secret passcode. Oh, I messed it up that time. Yeah. All right, let's go to the computer and I'll show you how this is happening.
All right, everybody. I've got y'all in Thorny here. So I'm going to show you the computer side of it and what's going on. First, I'm going to stop it real quick just so you can see the initializing stuff. Otherwise, this is going to print so much of the console so fast that we're not going to be able to see it. So I will show y'all that. These are the initial capacitance values of the surface of these pennies. And I was printing this a different way during my testing, not in a chart, and I got tired of messing with the indentation there, but it was good enough for this. Um, the way this project works is the ESP32 board has an internal capacitor which is wired to several pins, and what it will do is it will send a voltage across that, charge that capacitor, well, charge that pin, and then flip the polarity to discharge it and measure the amount of time that takes. So this is the baseline, the raw value, the amount of time it's taken to do that on each of the four pennies that you saw on that 3D print. And the only thing on the bottom of them is I soldered a wire to it, and then soldered a header pin so that it could go on the breadboard, and that's all we really have going on here. Now, with the capacitor, our skin is conductive. So if we touch a surface that is wired in with a capacitor, we're going to increase the amount of time that it's going to take for that capacitor to charge because it just got more surface area. So I'm going to start this back and I will go touch the buttons so that y'all can see what it looks like on here. And boy, that is going fast. Maybe that'll should still be able to see it. Yeah, you can at least see the buffer. One, two, three, four. Hold two at the same time, and it's counting seconds on how long I'm holding them to. Like I know it's flashing super fast there, but you'll be able to see at the end. And then the weird, the little secret sequence, with the three, 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 one, two, one. Yeah, secret sequence activated. Oh, yep, shoot. Oh, well, yeah, I already did multiple ones. Look at the baseline there. So what's happening is a raw value is being compared against it's measuring it twice. We took a raw value just to know what to set the threshold at to trigger it to turn on the light, and then it takes a second measurement, and that's showing the baseline, delta baseline, the change in baseline. Notice how I've got my fingers away from it right now. So we have a small change occurring on each of them. And I set the threshold to be 1,000. There has to be at least a change of 1,000 to activate the lights. But now here's something that's interesting. I am not touching them, but I'm holding my hand above them. because we have electromagnetic fields around our bodies and stuff. So without me even touching them, it's triggering several of these. I'll try to hold my finger over 3 without. Oh, I touched it that time. Yeah. So just hovering, it's not quite going over the 1,000 threshold. But then if I touch it completely, you can see it goes well over 100,000. The change in delta, and then I'll touch another one, and then another one. And another thing with the blend, so I've got my finger held completely on 2, and I'm just gonna barely start touching 1. So you see how it's going up some, but not as much as 2. Now if I hold my finger down completely, wow, look how much it shot up that time. 500,000. But all right, let's dig through some of this code now. I want to stop this loop. Scroll back up here some if I can for y'all so y'all can see kind of what was going on there. So that's when I was holding both of them down pretty firm. Just prints these loops so fast. It's so amazing how fast these microcontrollers run. Yeah, we're already to the top of the console. There's where it was showing how long I had my finger held. And it finally jumps from 11 to 12. But all right, so for this project, we need the pins and we need touchpad, NeoPixels for the built-in LED on the board, which is what y'all saw in the other video, changing colors. And then we need the time library because we need to induce some delays. And if you want to check out the GitHub, take the time to read all that, you can. I'm not going to read it for y'all. This is a little helper function I designed. I'm imagining it's only going to work with the esp32 unless you change the range. And remember, we don't start at 1, we start at 0, and therefore, you wouldn't have 0 to 39 is 40 values. So off by 1 errors, don't get caught by that. What this will do, though, is it will probe every single one of your GPIO pins, general input out, general purpose input output. There we go. It'll probe all those and let you know if they're touch capable and then what their capacitance value was, like this raw. And otherwise, it'll say no, it's not. So just copy and paste that function, run it by itself, and you'll have an idea of which pins can do it. These are where the header pins go for the wires to the back of the pennies. Those are the GPIO ones that I was using. And the reason why I had to write this helper function is because I was originally trying to do 4, 6, 13, and 15 based off of a Google search, but it turns out that 15 is not an applicable pin for my board. I think it's actually wired to boot, so couldn't use that one. These are the base colors, and there is a function to blend these, but touching each of those pennies respectively would change it to those colors. There's where we initialize NeoPixel, give it pin 48. That's unique to the S3 board. Here's where we pull in, initialize the touch pins. Because you don't have to wire it to a penny. Like you can literally just touch the pin on the board and it'll have the same effect. The reason why I use the penny is I wanted to explore unconventional buttons. Like if you had a huge row or a huge array of pennies on a wall, flush with the wall, and wires on on the back of just a few of them, only you as the designer would know which wire is on which penny, and then you could make like combinations for a secret door or anything. Endless possibilities. You could use pennies to control a game. I mean, so many options. But so that's what's up with that. You can just touch the pins directly though if you want to. This is where we're taking the baseline for the raw. Actually, this is where we're taking the baseline for where I started it, stopped it real quick, and showed y'all that. So that's what's up with that. This is the delta threshold, where I was talking about how, right there was only a difference of 106 in that initial raw reading versus the next one. So because it's less than 1,000, that light does not activate. But because this one is Is that million? Let's see, 1, 3. No, 500,000. That's well above that. There you go. Touch hold duration, I put that on there just so the LED would stay lit just for half a second, not just let off as soon as you let go with your finger. But you can program that to do that, or you can have it stay longer if you wanted to. This debounce was added to prevent numbers from being added multiple times. Like that's somewhat of a delay. Otherwise, like you might press 3, and then as you're releasing, it might include it again because of the changes in baseline and delta. So that's what's up with that. Feel free to tweak that around if you have any issues. For some of our other logic down through here, the last time each penny was touched, when each touch began, how long the penny's been held, and that tracks if that was another prevent the same number from being added multiple times so by accident. Kind of check right there. This was our secret sequence just to show y'all that it can be purposefully used. I mean, it's not just a gimmick. And here's our main loop. So we bring in the time, start our arrays for pennies that have been touched, and this weighted colors array. I'll show you all that down through here. There's the fancy printing that's not properly aligned. So here's where we get our touch pins in. I don't know why I put pads. I should just put pins. Leave it to me. Read the raw, calculate the delta, raw minus baseline of the one that we're focused on in this loop, and print it. And here's where we detect if it exceeds the threshold or not. So if it exceeds the threshold, and this is where we prevent it from being added multiple times by accident. But we add it to the sequence buffer. We set the current time to the last sequence time. Set that to true. Compare that. I think that was to keep that was to keep this queue moving and cleared out. That way, because otherwise it was doing it like I don't remember exactly how to explain how it was doing it, but it was doing it really weird. Yeah. Yep. It's all coming back to me. There's where we're tracking the duration of how long my finger was on the pin for. Yep, and this is where we're adding to the weighted colors. We're adding the color of the one that's being touched to the weighted colors list. And then we print the bottom of that little chart, which probably could have been included like way up here, but none the matter. So this is where we're printing the summary here, which penny was touched, how long, and if we have multiple pennies being touched, then the way that's set up, it'll just append them on there. And then we print the current sequence buffer with each iteration so that we know if it's changed or not. And that's the other thing with this. You could, once you have this data coming in, you could do anything with it. Like it doesn't have to just be printed to a console. You could have this sent over a network socket or anything. Here's where we're checking to see if the sequence matched that. And I would love to have stopped it on that for y'all, but I believe it is done cleared from the console. Maybe if you've got ninja skills, you can pause the video right where it was deployed at, and you'll see it. But basically, it's just printing this, and it flashes through all of these colors. And then we clear the buffer after a trigger. In case you wanted to immediately do it again, just to clean things up a little bit. This is where we're blending the color based on the delta strength. So, like right there, those are pretty close. That's probably going to be an even match. But right here, the color that's associated with Penny 2 is going to be stronger because it has a stronger delta. And then, turn all the neopixels off if there's no recent touch. And then a short delay for responsiveness because, it's an electronics project and they like to chill for a minute. All right, everybody. I hope y'all enjoyed this. Like and subscribe. And if you guys have anything unique you want to see, let me know. If you guys are having any issues with anything you need some help with, holla at me. Peace.